Right, we're carrying on with this paper, biology paper. So we have here a picture, and they want to know what this is. And if you look, because it's talking about CO2, burning fossil fuel, decay, photosynthesis, respiration. I'm assuming that they're either drinking water, eating grass. Assimilation and what have you. This is the carbon cycle. Which process is represented by the letter W? Where's W? W is there. So they take fossil fuel, and when they burn it, it's called combustion. Okay, now the next question is X. Where's X? Right. The animals are respiring. So that is X is respiration. Right, remember this. Respiration goes on at cell levels in cells. Right, it releases energy. And it's different from breathing, which is ventilation. Which is the movement of air in and out of the lungs. In and out of the lungs. Okay, there you go. Name a group of organisms that is responsible for decomposition. So, the two that you should know is bacteria and fungi. Okay, carbon dioxide. Carbon dioxide is released into the atmosphere by decomposition of organic matter. The rate of decomposition depends on a number of factors. So we need to design an investigation. When that comes to mind, I think of CORMS and I look at the number of marks and it frightens me. CORMS. Right. So we want to find out how changing the pH of organic material affects the rate of decomposition. Right, okay. Let's run with that. A 6 marker. So they want to know changing pH. So I will set up a I will set up a range of pH values of organic matter. Right, organic material. What we're going to make sure is, right, if I use different types of organic matter, it might decay at different rates, even though I change the pH. So I will make sure that the organic matter, I will make sure the organic matter is of same species or variety. You can also make sure that it's the same age, because older matter might decay quicker than fresh, young, new matter. Right. how will you make sure it's reliable? Again, this is a standard answer. Yeah, I will repeat each pH value I will remove any anomalies and average out the results. That is a standard answer. You don't need to even think about that. Right, what will you measure? That's a good one. What you can do is, I will say, I will measure the loss of organic matter. Right, so you have a mass before and minus mass after. Right, and I will measure this. I will measure it after, let's say, 1 month, 2 weeks, whatever you want to do. Yeah, something sensible. And then finally, what you're going to keep the same, what your control variables the same. Right, we know things like I will make sure the temperature, oxygen levels are kept the same. I will also make sure the humidity levels are the same. Humidity. All this affects the rate of decay. The same. That's it. So that is a Corms question. That's interesting. That is, yeah, they put it in as a question 3 in paper 1. Okay, that's nice, interesting one. Oh my word, does that mean? Yeah, that means a graph. Come on then, let's get on with it. Right. The data in the table was collected in Japan during a 7-year study. Scientists collected data of age of mothers, whether they smoked, recorded the percentage of babies that had low birth mass. So let's have a look here. Who did not smoke and who did smoke. Those who did not smoke, percentage with low, so 11%, and it changes by age, and smokers generally higher. Okay, there you go. Okay, there's low numbers here. So if you look here, there's a low number of subjects or participants in the survey. Well, those the data that they've studied. Right, calculate the percentage of mothers under the age of 19 who smoked during pregnancy. Right, what you do is under 19 who smoked. So we're looking at this bit here. So it's 356 out of a total of we add all them. Hang on. Oh, right, okay. Agent who smoked. Right, okay, no, they don't want that. They want only under 19s, not of the total mothers. Right, okay, yeah, so we need to add these two. So we do 1331 plus 356. How do you turn a fraction into a percentage? You multiply by 100. And your answer should be 21.2%. Right, okay. Determine the ratio of non-smokers to smokers in the form n to 1. So what you do is non-smokers, add all them, smokers, add all them, and you get 85,147, 7,206. So we write it 8, so smokers, sorry, non-smokers to smokers. So 85,147, 7,206. Right, no, don't say that. Bear with me one second. Right, let's carry on. Yep, it works now. Right, and they want in the ratio, they want this as 1. So what we're going to do is divide this by 7, 2, and then we're going to divide this by the same number. So we end up with 1 there, and we end up with 12. Well, it starts, it's 11.82 to the nearest whole number. It will end up as 12 to 1. There's 12 to 1. Did that? 12 to 1. Right, okay. 6 marker coming up. Right, student examines the data and concludes smoking is the main factor behind low birth mass. Use the data and your own biological knowledge to comment on this conclusion. Is it true? Yes. First of all, yeah, we can agree with that because the percentage or the ratio or the percentage of low birth mass for smokers is higher. Also, they've used thousands, haven't they? A large sample size has been used. Right. Now we could also say not really, because if you look, right, for age there's a lot of difference, but for the younger ones there's not much difference. But as you get older, it doubles, almost doubles, well, more than doubles. So we can say age has a large effect. Large effect has a large effect. It affects, it has a large effect. What's the difference between, that's 50%, that's 100%. It has a large effect. Right, people over 35 years old smoking has a greater effect Yeah. Right, and again, because the older mothers, we don't know, may have smoked for many years. Right, rather than the age. It's the fact that they've smoked over many years, so there's a lot more damage. There's no information, and this is what normally happens when there's no information on the weight of mothers or the height. So in comparison to how big they are when they give birth, you expect a large child. You would do. There's no information on lifestyle. For example, drinking, exercise, type of work they were doing, just general diet, etc. There was no information on frequency of smoking. Are they heavy smokers or just casual? On smoking habits. Okay, that's cool. Right, let's move on. Scientists carried out experiment to see if reducing availability of oxygen affects production of yogurt. They use increasing acidity measures as a measure of yogurt production. Okay, they record the acidity of two cultures, one with reduced oxygen level, one with normal, over 210 minutes. So what they're saying is there's two types here. You've got reduced and you've got normal. So just say after 60 minutes, the acidity's gone up. After 2 hours, acidity is going up quicker. So this is anaerobic respiration. 3 hours, and then eventually, so basically that looks like as if the yogurt production is complete whilst that's still going up. So that's what it looks like. Explain why the increasing acidity can be used as a measure of yogurt production. Right, that's because the respiration produces lactic acid. Right, we can say anaerobic respiration by lactobacillus, or by the bacteria we put in. Respiration by bacteria produces lactic acid. Okay, give one abiotic. So you have biotic factor, which is something that was that had some life in it, and abiotic factor, something that was dead. So for example, the air or the water or the minerals should control I don't know, temperature is the most obvious one. Temperature. Right, okay. They've also said volume of milk, the type of milk, because they'll have different levels of natural acidity and lactose levels and etc. Right, okay. So now we need to plot this Let's go get that. Second. Right, let's just there you go. Right, we can now plot this. So we'll put the time here on the x-axis. So you've got 1, 2, 3, 4, 5, 6, 7, 8. So if we call this 0, call that 8, so that'll be 1, 2, 3, 4, 5, 6. Okay, let's do this 2. So that'll be 30, 60, 90, 120, 150, 180, 210. There's 30, 60, 90, 120, 150, 180, 210. Oh, we can get away with that. So just spread it out right to the end. Let's just read. 30, 60, 90, 120, 150, 180, 210. This is time, and in brackets just put in minutes. Right, up here we've got acidity percentage, and then we're gonna, so it goes from 0.2 to 0.7, so 0.2, 0.4, 0.6, 0.8, so 0.8, 0.6, 0.4, 0.2, and 0. Right, all those we'll use two different colors, so we'll use green for these values. So it's 0.2 at 30 is 0.2, 0.22. Right, so this is where you've got, that's 0.3, so that's 0.2, 0.25, that's 3, so you've got to be careful, you're within half a square. 120, 90, 30. Really? Did I just do that? I did, didn't I? You know what I'm going to do is I'm going to see if I can cheat. No, I can't cheat. Yes, I might be able to cheat. What this? Just going to cheat. It's not good. But let's do it. Okay, 90 is 0.4. 120 is 0.5. 150 is 0.62. 180 is 0.7, and then it levels off. So straight line, so it says join straight line. So I'm going to pretend I've got a ruler. Right, you're not allowed to do this. You have to use a ruler when you're practicing, because if you get into the bad habit, you might lose marks for no reason. Right, so we need to write a key. So this is reduced oxygen levels. So this is a key. Let's use a red one then for normal oxygen levels. Right, 0.2. It goes to 0.22, 0.24. It's just there. 0.25 is there. 0.31, 0.41, okay, 0.51, 0.70 there. So this is going I've done a dotted line so then I didn't hide the green line underneath that. So these are straight lines. Right, okay. Explain why the changes in percentage are different in reduced oxygen levels. Right. So you have less oxygen, so more anaerobic respiration takes place. Respiration happens. And so you have less aerobic respiration. And remember, anaerobic respiration produces lactic acid. So the lactic acid is produced quicker. Okay. Right, where are we? 26. Right, we'll call it quits at that.